Okay, so today I'm going to introduce something called the Snell's law. So, what is Snell's law? Snell's law is something like a formula which can be represented by n1 sine I equal to n2 sine r. So, what is the n1, the n2, I, and r? So, remember what is I? I is the angle of incidence. So, I is the angle of incidence, and we know that angle of incidence must be always be in the less dense medium. Okay, then for R is the angle of refraction. So this must be in the more dense medium. Right? Okay, then of course, what is N1 and N2? N1 and N2 just refers to the refractive index of two different kinds of medium. So for example, N1 must always be the less dense medium, and of course N2 must be the more dense medium, because N1 corresponds to I, then N2 corresponds to R. Right? So let me just give you an example. So for example, if I have something like this, I have a boundary and I have air and I have maybe glass. So let's draw a normal. Then after that, I draw a light ray. So this light ray will make an angle with the normal. So this is known as the angle of incidence. Then after that, when I go into glass, I'll bend towards the normal. So this will be the angle of refraction. But of course, I can also give you another scenario where we have this same boundary, air and glass. But instead of the light, right, traveling from air to glass, now I have a opposite direction. So for example, I have a normal. After that, okay, this one is the glass, this one is the air. Alright, okay, so now the light travel from glass to air. So of course, now this is not the angle of incidence. This will be the angle of refraction. Okay, after that, when you go into air, this will bend away from the normal. So this is known as the angle of incidence. Yeah, so every time you do your calculation, always remember angle of incidence will always be in the less dense medium, whereas for angle of refraction must always be in the more dense medium. If you do it other way, you will get a refractive index less than 1, which is wrong. Alright, so just think of this very important concept. Okay, so let me just go back to the Snell's law. Okay, Snell's law, n1 sine I equal to n2 sine r. So n1 must be the less dense medium, n2 must be the more dense medium. Okay, so actually for this Snell's law, we actually learn a very special case where we learn how to calculate the refractive index of a particular medium. So we know that n equal to sine I over sine r. So this n equal to sine over sine r is actually being derived from Snell's law. Okay, so let us see how is it being derived. Okay, so let me refer you to case 1 where we have this very special case, right? Okay, so assuming that we have two medium, one is air, okay, the other is known as a medium. So let me assume that it is glass. Okay, so first thing first, the light travel from air to glass. So this will be known as angle of incidence. This will be known as the angle of refraction. Okay, so we apply the Snell's law. N1 sine I equal to N2 sine R. So N1 is what? N1 is actually the refractive index of the less dense medium, which is the air. Then N2 is the glass, the refractive index of the glass. Okay, now we do a bit of substitution. N1, we know that N1 is air, right? So air, we have a refractive index of 1. That's why I just replace N1 with 1. So 1 sine I equal to N2 sine R. Then we move the sine R to the left hand side. So you get sine I over sine R equal to N2. So N2 is the refractive index of the glass. So of course, I just get rid of the 2. I'll get n equal to sine I over sine R. So this is a very special case of Snell's law. Okay, however, to use this formula right here, not every question we can use this formula. So the question that we can use this formula is where one of the medium is air. So for example, I have air glass. Okay, if I have air glass, I can use n equal to sine I over sine r. Okay, another example, if I have air water, I can also use sine I over sine r. But if let's just say I have something like this, air, no, not air, sorry, water, glass. So if I have water glass, I cannot use n equal to sine I over sine r. I must use the full form of the Snell's law. Okay, so let's take a look at one of the examples. So of course you can look at case 2. Case 2 is where I have water, I have glass. So in this case, I cannot use n equal to sine I over sine r. I must use the full form of n1 sine I over equal to n2 sine r. So okay, let's take a look at this case 2 first before we go to the try yourself one to learn how to calculate. So very first thing is you can see there's a water and glass. So we know that the angle of incidence is 60 degree. Then the angle of refraction, which is inside the glass, is r. So of course, let me put in some numbers, 40 degree. So how do I use the Snell's law to calculate? So first thing first, always write down the formula. N1 sine I equal to N2 sine r. Second step is to determine all the different parameters. So for example, what is the I? I is equal to 60 degree. R is equal to 40 degree. Then of course you must also determine which one is the less dense medium, which one is the more dense medium. So this one is actually very easy to determine. You just look at the picture, you will know already. So if you look at the light in water, so the light in water actually is not very close to the normal. So means that this must be less dense. Then for glass, right, you bend towards the normal. So means that this is more dense. Okay, so that's how you determine which one is N1, which one is N2. So N1 is the water. Then N2 is the glass. Then you can just use the third step. You can just put in the numbers already. So for this particular example, so for example, if I want you to calculate the refractive index of glass, I must give you three things. I must give you first thing, I must give you the angle of incidence, angle of refraction, and of course the refractive index of water. So for example, if I give you this water refractive index, right, so it's about 1.33. So I can simply just sub in. So for example, right, N1 sine I equal to N2 sine R. So what is N1? N1 is the refractive index of water, 1.33. Then the I is 60 degree. The N2 is something that I want to calculate. R is 40 degree. Okay, so let me do a very quick calculation. 1.33 sine 60 divided by sine 40. So you will get a refractive index of roughly N2, right, is equal to 1.79. So that's how you use the Snell's law to help you calculate this type of question. So let us take a look at this try yourself one. So first thing, assuming that substance X has a refractive index of 1.6, determine what is the refractive index of substance Y. First thing, always write down the formula. So first step is write N1 sine I equal to N2 sine R. Next step is to determine all the different parameters. So for example, so you can see that the angle right here is 40 degree in substance X. Then after that, for substance Y is 20 degree. So you can see that it's quite simple to see which one is the less dense, which one is the more dense medium. So for substance X, definitely is the less dense medium. Then substance Y is the more dense medium. So since substance X is the less dense, right, so I give it N1. Then for substance Y is N2. Then for 40 degree is I, 20 degree is R. So you just simply write down what is the different parameters, right? So angle I is equal to 40 degree. Angle R equal to 20 degree. So N1 is the substance X refractive index of 1.60. The N2 is something that I want to find. Then you just sub in already. So third step is to sub in. So N1 is 1.60 sine 40 degree equal to N2 sine 20 degree. So you can simply just calculate 1.6 sine 40 divided by sine 20. So it's roughly, so the N2 is roughly 3.00. So the refractive index of this substance Y is actually 3.00. So that's how we use the idea of Snell's law to calculate. Okay, so another very similar example, again substance X and Y. So assuming that substance X has a refractive index of 1.5, determine what is the refractive index of substance Y. So very first step, N1 sine I equal to N2 sine R. Okay, then second step, you determine all the different parameters, right? So we know that X, the angle of this angle is 40 degree. Then for substance Y, we have an angle of 20 degree. So you can see that my X is the less dense medium, Y is the more dense medium, right? So X is less dense, Y is more dense. So of course I give it X as N1, Y as N2. Okay, next step, you just, of course, I do a very fast calculation. So N1 is 1.5 sine 40 degree equal to N2 sine 20 degree. So in this case, you can calculate what is your refractive index of substance Y. So 1.5 sine 40 divided by sine 20. So you will get a refractive index of roughly 2.82. So that's how you use the Snell's law to help you calculate. Alright.